Thank you all for coming. Because of their role as apex predators in the marine environment, sharks are ecologically and economically important animals. However, due to decades of overfishing and poor management, populations of sharks around the world are declining at alarming rates. This figure comes from a 2007 Science paper and shows population declines of 90% or more since the 1970s in 5 species of sharks found in the northwest Atlantic Ocean. A new way of managing shark species is needed, and an emerging paradigm in fisheries policy is ecosystem-based fisheries management. This holistic approach to fisheries management incorporates diet and trophic relationships into fisheries management plans instead of simply relying on the single species that you manage. One species of particular concern to the National Marine Fisheries Service is the sandbar shark, Carcharodontis quinquetus. These animals are found globally in warm and temperate coastal waters and are responsible for more than half of the United States commercial shark fisheries. They have an extreme case-selected life history, taking more than 15 years to reach reproductive maturity, at which point they have fewer than 10 offspring every 2 or even 3 years. The National Marine Fisheries Service is specifically interested in an ecosystem-based fisheries management plan for sandbar sharks. They requested in their 2006 Southeast Data Assessment and Review for large coastal sharks and sandbar sharks. The traditional method for determining diet data in sharks is stomach content analysis, which usually involves cutting open the stomach of the shark to see what's inside. While direct and effective, this method has many drawbacks, not the least of which is that it involves sacrificing large numbers of the very species we're gathering this data in order to conserve. In some cases, thousands of animals for a single stomach content analysis project. Sandbar shark diet has been studied using stomach content analysis in 2 distinct parts of its range, Virginia and Hawaii. Both of these studies noted an ontogenetic shift in diet, with younger, smaller sandbar sharks feeding primarily on crustaceans such as shrimp and crabs, and older, larger sandbar sharks feeding primarily on teleosts and small benthic elasmobranchs. It is not known if this ontogenetic shift occurs elsewhere in their range. In some species of sharks, diet is drastically different in different parts of the world. These ontogenetic shifts in diet are extremely important for ecosystem-based fisheries management. If you're managing a species based on what it eats, you need to know if different life history classes eat different things. Some authors have even suggested that different age classes of certain species be managed as separate species under ecosystem-based fisheries management plan. The goals of this project were to determine the diet and trophic level of South Carolina's population of sandbar sharks, something that has never been done using any method before, and to promote the use of minimally invasive, non-lethal methods such as stable isotope analysis. Stable isotope analysis has never before detected an ontogenetic shift in the diet of a wild population of sharks. We hypothesized that diet and trophic level, represented by carbon-13 isotopes, will vary by age class, but not by sex, estuary, or year. And we suspect that our stable isotope analysis will show similar trends as the earlier stomach content analysis. For those of you unfamiliar with stable isotope analysis, here's how it works. As a predator eats prey, atoms from that prey are incorporated into the predator's body through the processes of digestion and growth. Some of these, known as stable isotopes, serve as natural biomarkers which can be traced as they move through food web. And though many stable isotopes exist, this study focused on the use of carbon-13 and nitrogen-15 isotopes. These behave differently as they move through a food web. Carbon-13 levels vary in change with trophic level. So the carbon-13 signature of a predator can be used to trace the original carbon source of the prey and answer questions such as, is this predator primarily eating benthic prey or pelagic prey? Is this predator primarily eating coastal prey or offshore prey? Nitrogen-15, on the other hand, changes in a predictable stepwise fashion with trophic level. And a change in approximately 3.4 of the nitrogen-15 signature is associated with the full trophic level increase. This method was applied to South Carolina's sandbar shark population. We sampled 5 estuaries in coastal South Carolina: Wignon Bay, Bulls Bay, Charleston Harbor, St. Helena Sound, and Port Royal Sound. Sharks were sampled through the cooperation of the South Carolina Department of Natural Resources Coastal Shark Survey and were captured by longline. Whenever a sandbar shark was captured, a small muscle sample, approximately 2 grams, was taken using a biopsy knife. You can see the muscle sample there, leaves a very small mark in the shark, actually a smaller mark than is used by the pads that we were already using. So this technique is much less invasive than stomach analysis. All sharks were measured, both fork length and total length, sexed, tagged, and released. And after being processed to remove the excess urea common in shark muscle tissue, samples were processed in a mass spectrometer configured for stabilized samples. This figure shows where we captured different age classes of sharks within this 5 estuaries. Number of sharks is the x-axis, the y is our different location. The age class definitions that we used were the same as those used in the Virginia and Hawaii stomach content analysis study to allow for easy comparison to the earlier work. But young years were defined as animals less than a year old that were less than 58 centimeters fork length. We captured 77 of those. Juveniles or animals between 58 and 140 centimeters fork length. These are usually between 1 and 10 years old. We captured 180 of those, and we were able to capture only 8 adults, of which most were female, and were likely coming into the estuary in order to give birth. These are animals larger than 140 centimeters. This sample size is noteworthy. As of January of 2011, 27 shark species have had their isotopes analyzed, and of these, 3 had a sample size larger than 30, and 0 had a sample size larger than 75. So these sample sizes are extremely significant. We also found no significant differences in either the carbon-13 or nitrogen-15 between our 2 sampling years, 2009 and 2010, between males and females, or between the 5 estuaries in South Carolina, indicating that there is no difference in diet between sexes, between years, or between estuaries. However, we did found a significant difference in both carbon-13 and nitrogen-15 between young and year and juvenile sandbar sharks, which you can see here. Let me orient you to a stable isotope analysis biplot. The x-axis is delta carbon-13, which is a ratio of heavy carbon isotope to regular carbon isotope. Left on this axis indicates more coastal, more benthic. Right indicates more offshore, more pelagic. The y-axis is delta nitrogen-15, a ratio of heavy nitrogen isotope to regular nitrogen isotope, and higher on the y-axis indicates even higher trophic. The symbols here represent the mean of our subgroups, in this case, young of year and juveniles, and the error bars represent 1 standard error. So a note that found significant differences between the carbon-13 signatures of young years and juveniles, as well as between the nitrogen-15. This likely indicates an ontogenetic shift in diet. If these animals were eating the same types of prey, they would have the same isotopic signature. So a difference in isotopic signature likely indicates an ontogenetic shift in diet between young years and juveniles, similar to the one found in Virginia and Hawaii using lethal sampling methods. So this graph is the mean plus or minus the standard error of all young years, all juveniles. This is the same data, but it's every data point. There are 3 metrics that are commonly used to assess diet variability using isotopic data. These are delta nitrogen-15 range, which is the difference between the 2 most extreme nitrogen-15 points. Delta carbon-13 range, the difference between the 2 most extreme carbon-13 points. And total occupied niche area, which is the convex hull area of the polygon that is the outer boundary of your points of isotopic space. The dark points represent juveniles, the open points represent young and year. There's a few things that you can take away from this. One is that the nitrogen-15 range, carbon-13 range, and total area, represented numerically here, is always larger for juveniles than it is for young and year. What that means is that juveniles have a much more variable, much more diverse diet than young years do. That's something that has also been found with stomach content analysis studies of sandbar sharks elsewhere. The other pattern that you can see here is that the majority of the young year points, which are these open squares, fall within the larger juvenile cloud points. There's a lot of overlap between the young years and the juveniles. But there are lots of juvenile points that do not have young of year data points near them. What this indicates is that as sandbar sharks age and get larger, they gain access to new prey species that young of years cannot access, but they do not lose access to the prey species that they used to feed upon. This is a common pattern found in many species of sharks and has been backed up before by stomach content analysis data of sandbar sharks. So in conclusion, the carbon-13 and nitrogen-15 signatures did not vary by year, by gender, or by estuary, exactly as we hypothesized. The younger year and the juveniles have different carbon-13 and nitrogen-15 signatures, which should suggest that we have detected an ontogenetic shift in South Carolina's population of sandbar sharks. Again, this is the first time that an ontogenetic shift in diet has been detected in a wild population of sharks using non-lethal methods. Juveniles have a larger total occupied niche area, larger nitrogen-15 and carbon-15 ranges, suggesting a wider diet among juveniles than among young of year sandbar sharks. And overall, what we can take away from this is that minimally invasive non-lethal methods, such as stable isotope analysis, can reveal information that fisheries managers need and is traditionally obtained by sacrificing large numbers of animals. I would like to thank the dozens of people in 7 labs in 3 states that helped make this research possible. My committee members are underlined. I'd like to acknowledge my sources of funding and thank my numerous field volunteers. Thank you for listening.